Hey, hello everyone. So today we are going to talk about a very important topic, and yes, it's very important topic in organic chemistry because yeah, we are going to deal with the chirality. Okay, so let's see first of all a very wonderful molecule, a 3D diagram over there, right? Yes, it's so nice to study over here. Okay, so let's talk about the chirality and achirality. So what is that exactly, and why it is very important? So in the whole session, we are going to talk about what is chirality. That is the first point, how you can define a molecule can be chiral or achiral. That's the second point. And the third point, how that chirality makes that molecule optically active. So we are going to talk about these three very important points in this session. So let's start it, right? So before we go ahead, you can see the molecule is rotating over there. This is a 3D diagram, and this is going to help us a very well understanding or give an insight of the chirality in a very 3D model. Okay, so let's talk about that. Okay. Okay. So what is the first of all? The first most point comes in your mind is what is a chirality, right? So let's talk about what is a chirality. So when I talk about the chirality, okay, so it's a property, or we can say the property exhibited by the molecule when the valence is fulfilled by the different atoms of carbon. So first of all, before we go the look into the definition, let's talk about that. See, we know that in our organic chemistry, carbon is very important. Why carbon is very important? First of all, the carbon is tetravalent. The carbon is what? Tetravalent. What is the tetravalent? The valency of carbon is 4. So we know that the rule of octet and rule of duplet, right? So according to rule of octet, the any atom which has to be stabilized required at least 4 electrons should be revolved around the valence shell. But look at the carbon. Okay, it's a very unique. Why? Because in the carbon shell, there are how many electrons are there in a last shell? 4 electrons. Very good. Okay, and because of that, don't you think so? It's a half of that 8 electron, that is a 4 electron. And because of this 4 electron, the carbon valence is tetravalence, right? And because of this tetravalency, the carbon is going to form a covalent bond. How? What is that? Covalent bond. That is sharing of electrons. Yes. And that's why the carbon is present abundantly in the nature. Okay. And that's why in a whole organic chemistry, we are going to deal with the carbon, right? Yes. Those who love the chemistry, that is organic chemistry, they know how the carbon abundantly found in the nature and why. So these are the two reasons we have just covered over here. Okay. So let's go further and try to understand. Okay. Try to understand the next thing. So chirality. So when I talk about the chirality, okay, the carbon, it's going to revolve around the carbon. If the carbon valence is what? 4 is fulfilled by the different groups of the atoms, that means A is not equal to B is not equal to C is not equal to D. So they are different atom A, B, C, D should be there. Why only 4? Because tetravalence is there, that we know that. So A, B, C, D should be different, right? That is most important point that we have to understand, isn't it? That is very important to understand, right? Yes. So that is what we are going to talk about, the chirality. So how can you define the chirality? Can anybody tell me right now? Yes, the chirality is a property exhibited by the carbon which, or we can say the valency of center carbon. Yes, why center? I will tell you. Center carbon is fulfilled is fulfilled by different group of atoms. Yes, exactly correct. So the chirality is a property exhibited by the center carbon, okay, that fulfilled by the different group atom. So before we look into this model, just I want to tell you one thing. If I have a carbon, hydrogen is attached, OH is attached, okay, bromine is attached, and here next CS3 is attached. Now according to the rule of chirality, what we can indicate that 4 different groups are attached, isn't it? Hydrogen, bromine, oxygen, I mean hydroxyl group and the methyl group. So don't you think this carbon is going to mark as asterisk? Oh, why are I going to mark that asterisk like this? Because chirality has been shown by this mark. And whenever there is an asterisk mark is there, that is called the center carbon. First of all, obviously that has to be center carbon, and that is a asterisk mark, asterisk sign. What is asterisk sign? Like this is above the carbon is there, and that indicates the chiral. That means different groups are fulfilled by the, yes, the valency is fulfilled by the different group. It's called the chirality, and that carbon center is has to be marked with this sign. So whenever you in the compound you find this kind of mark, that means that compound or that molecule have the chiral center. Exactly correct. Now question is it possible to have a different chiral center at the same molecule? Yes. So we will see that later on. Before that, just talk about this a very wonderful 3D diagram. Okay, so let's talk about that 3D diagram. Okay, so this is the here. Now tell me one thing, as we discussed chirality. Chirality has to be what? Fulfilled by the different groups, right? So look at this group and this group. Now let me highlight this. So this is a center carbon. Okay, that is red color, the center carbon, right? Okay. Now this is another group is attached here, another group attached here, another group attached here, and another group is attached here. That is already red in color. Okay. So now let's talk about that. This is the first group, this is second group, third group, and the fourth group. For the chiral, how can I define that is a chiral center? The fourth group, A, B, C, D, or 1, 2, 3, 4 are should be different. So first is a different. Second has a alkyne, that is carbon carbon, that is carbon carbon. Triple bond is there. So there's a different group from 1 and 2. So one group is different, second group is different. But now there is a problem. Look at the third. That is, if I draw carbon, this is H, this is H, and this is H. This is resemble to that, and this is also resemble to that, isn't it? Yes, exactly. That's what I'm trying to say. Okay, so don't you think so? Now our criteria to define that molecule should be chiral is not fulfilling. Why? Because 1 is not equal to 2. 2 is not equal to 3, but 3 and 4 are equal. That ABCD we talk about, right? Now this is center is not chiral. So this is called a chiral center. That means two groups, minimum two groups are same. So 4 and 3 are same. Because of that, this molecule is called a chiral. Okay, let me talk about again. A chiral center is a one who has minimum two same group. Okay, if there are different four groups, it's called chiral. Okay, so what we have just studied over here, first is a chiral, another one is a chiral. Okay, in chiral, the four groups are different, and in a chiral, minimum two group which is attached, group of atom which is attached or atoms, okay, are same. It is denoted by asterisk mark. This is not denoted at all. Okay, this is not denoted at all. So this is a chiral and a chiral. This molecule, it is a chiral. Why? Because two atoms are same. Now, if I make a change into this, suppose instead of this molecule, I'm erasing this. Okay, just try to understand what I'm trying to do. Okay, let it rotate. See, it's beautifully rotating, right? Yes, and that's a give inside of the theory, and that is a wonderful, right? So now, instead of this bond, if I drawing over here C2H5. Now, student, tell me this group is right now what? A chiral, and have to mark asterisk over here with this carbon, right? Why? Because here is a ethyl group and here is a methyl group. So don't you think so? All valency got fulfilled by the different groups, isn't it? So that's called chiral, right? So I just have make one change and that molecule become from a chiral to the chiral, right? Have you understood this point? Yes, very well done, very well done. Okay, so now we have covered this. Now I will tell you something. The third point we are going to discuss. What that point? How that chirality helps the molecule to rotate the plane polarized of light. Oh, what is that? That's called optical activity, right? So let's see. 1, 2, 3. Okay, that kind of molecule I want to prepare. Suppose I'm joining this with this group. This is a bond. Okay, this is one and this is second. Okay, now the different group is attached over it. For example, just for your understanding purpose, I'm doing this. Okay, now tell me one thing. There are chiral center. Why there is a chiral center? 4 different groups are attached. Okay, and because of this attachment, there is a optical activity. There is what? Optical activity. And what is optical activity? Yes, the optical activity is nothing but what? If a plane polarized light. What is a plane polarized light? A single beam of light. See, white color is a combination of all the colors that we know that. If I'm taking from the rainbow with God, if I'm taking orange color, that is a monochromatic light. Yes, that is a monochromatic light. So plane polarized light means what? You are just taking one single beam of light. Okay, there is no different chroma. Chroma means what? Color. So monochromatic single color you're taking. That's called plane polarized light. Okay, if the plane polarized light is get rotate by any molecule is termed as is optically active compound. So if any plane polarized is get reflected, no, not reflected, rotated. Understand that point. Rotated. For example, if this is a molecule and the light is coming from here and is get rotated to the right side. Okay, is the another molecule is here and light is coming from here and it's rotated this side, left side. Okay, I'm just using color to show you. Okay, something very important. So the molecule which is responsible for rotating light to the right side is called the dextro-rotatory. Okay, and the one who responsible to rotate the light, that is plane polarized into the left side, is called levo-rotatory. But guys, we miss one point that is very important. You haven't tell me that. What's that? Yes. For any molecule to be optically active, the first most important criteria has to be followed is chirality. And once it's chirality, that means it has a center carbon, which is asterisk mark. Asterisk mark means what? It's a chiral center. So any molecule should be defined as an optically active compound, or rather we can say it should possess a chiral center. So here in this molecule, this is a chiral center. If plane polarized light come here, it may be rotate here or maybe rotate this side. So depending upon the rotation, it's named as a dextrorotatory or the levorotatory. So this is the point, right? So we have covered a very important point over here, that is optical activity. So what is optical activity? Just let me know. If the plane polarized light is get rotated towards the left side or right side, that compound is termed as optically active compound. And for that optically active compound, what is a very important point? That is a chirality. I mean, that molecule has to be chiral center. Why has to be chiral center? For rotation of the light. That's okay. But how can you term that molecule is a chiral when the center carbon is attached to different groups, and that's why it's called a chiral center. Now the question is that a chiral, understand, a chiral is able to rotate the light plane polarized? No, absolutely no answer. Okay, so only chiral compound having the carbon center, okay, which is a chiral one, is responsible for rotation of the plane polarized light. So my point is clear. Okay, so we have covered 3 points over here. Okay, so now see, I am not putting any molecule over here because that become a chiral. I'm talking about the chiral right now. So this compound should be different, right? This compound, let's talk about this C2H5. Okay, now what we have covered, just discuss. First, what is chiral and achiral? So what is a chiral one that we have discussed? The one, the valency of that carbon. Yes, organic chemistry, carbon related. So the one who is attach with a different molecule, that's called chiral. The second point, we talk about the achiral. If the valency of the carbon is not fulfilled by the different groups, that is called the achiral. And third is very important point, optical activity. Okay, if the plane polarized light is rotated towards the right or left, depending upon the presence of the chiral center, that compound is termed as or called as or declared as optical active compound. So these 3 points are very important points related to the chiral, achiral, and optical activity we have covered. Okay, so I just asked one question during the session. What's that? Is it possible to have a different chiral center in the group? So let's take example. If I draw this molecule, this is UH, this is H, OH, OH, H, and OCOH. Now look at very carefully about this carbon. Okay, what's that possess? Okay, so if we talk about this carbon, this is a different group, this is a different group, this is a different group, and this is a whole different group. So can I say this carbon center is a chiral? Yes, I can declare that. Very good. Now let's talk about this carbon. Okay, now let's talk about this carbon. This is this. Okay, now this is second carbon, right? Now let's talk about this is first, this is second, this is, let's talk about third, and fourth is a whole group. That is a, okay. So don't you think so? This carbon, the carbon 2, and this is carbon 1, both are what? Chiral. So is it possible? Now tell me one thing. Is it possible now to have a two chiral center in the same molecule? Yes, that is possible. Okay. So we have covered all the 3 points along with the extra point that is very important. So I hope you understood that. Okay. So stay tuned with us to understand more in detail with a very fabulous 3D diagrams. Okay. So, okay then. Bye-bye. Take care. Have a great day to all.